Today's program, Tall, Taller, Tallest, will be presented by Antony Wood, who is the Executive Director of the Council on Tall Buildings and Urban Habitat, which is responsible for the day-to-day running of the council. His field of specialism is in the design, and in particular the sustainable design of tall buildings. Based at the Illinois Institute of Technology, he is also an architect and an associate professor in the College of Architecture at IIT. He has worked in architectural practice in Hong Kong, Bangkok, Kuala Lumpur, Jakarta, and the UK. So please join me in welcoming Antony Wood.
Okay, good morning, everyone. I'm absolutely amazed that so many people will come out on a Sunday morning to hear about tall buildings. Amazed. So thank you, and very honored. This is my first experience of the Chicago Humanities Festival. As you can probably tell, I'm not a local. I hail from the United Kingdom originally. And it's an amazing program of events that are going on. And as I say, I'm very honored that you've all come to see my presentation. Tall, taller, tallest. We're going to talk about 4 things today. We're going to look at some definitions on tall buildings. What exactly is a tall building? We're going to look at some of the trends that have occurred in the past 10 or 20 years in tall buildings. What have been driving those trends, and what are the challenges for the future? Could I just ask, how many people are from a building industry background here? How many architects, engineers? Right, okay. Good, because I don't get into a lot of technical detail. I just want to see if there's anyone out there who's going to pick me up on something. Okay, what is a tall building? This is the question that I get asked probably more than any other question. And I'm going to tell you definitively that a tall building is a building that exhibits some element of tallness. And you know, although that sounds rather jokey, it's not, because I think it's very dangerous to say, well, a tall building is anything over 14 stories or whatever. And I'll tell you the 3 things that and when I talk about we, I talk about my organization, or the organization that I'm the executive director of, the Council on Tall Buildings and Urban Habitat, which has been in existence for 40 years and is based here in Chicago at IIT. We consider 3 aspects when we're looking at what constitutes a tall building. The first is it's not just about height. It's about height relative to context. And in some cases, you know, a 15-story building may not be particularly high, in this city, for example, but in suburban areas or in provincial cities in this country and other countries, it is particularly high. So it's not just about height, it's not about feet above ground, it's about height relative to context. The second is proportion. It's not just about height, but it's also about the size of the building relative to that height. So we can have some towers, for example, or buildings which are not particularly high, but they're very slender, and these could be considered tall buildings. I think a good example is just along the river here, the Merchandise Mart, which is an absolutely massive building in mass. And when it was built, it was actually quite tall. But it's not typical of a tall building because its mass is bigger than its height. And the third criteria that we look at are the technologies that are employed in the tall building itself. And if these technologies are specific to tall buildings, it could be elevatoring strategies, it could be wind bracing, then this is another factor that leads us to conclude that the building is a tall building. So, sorry, I should have explained, any building that fulfills any of those 3 criteria to us could be a tall building. What is a super tall building? Very easy. It's not a building that exhibits some element of super tallness. It's a building which is over 300 meters or 1,000 feet in height. So we do nail that down with definitive criteria. And just to put this in context, at this moment in time, as we talk about this, there are only 37 buildings in the world that are super tall, that are completed and occupied today, only 37 buildings which are over 1,000 feet in height. Now, it would be very amiss of me to come here and talk to a Chicago audience about tall buildings. And also, I can see people smiling in the audience already. One of the things that my organization does, we are the arbiter on tall building height and the body that says which is the world's tallest building or not. And some of you, if not all of you, may remember a situation about 10 or 12 years ago where the title of the world's tallest building was awarded to Petronas Towers in Kuala Lumpur over the Sears Tower. And although I just want to say for the record that I was not involved in that decision, because I was far too young at that time. I just want to explain some of the reasoning behind that, because it did, and I think it's fair to say, it surprised us the amount of interest that decision had, both in Chicago and around the world. The main reason is this. The antennae at the top of the Sears Tower were not included in the height of the building, as opposed to the spires on the top of the Petronas Towers. And the reason for this is that the spires were always considered an integral part of the architectural vision behind that building. So it was never expected that those spires would ever be taken away from the building. Now, over the past 30 odd years, the antennae on top of the Sears Tower have obviously become synonymous with the iconicness of that building. However, they were there for one reason and one reason only. They're a piece of telecommunications equipment. They were never part of the integral initial architectural idea. And in actual fact, part of the reason that, a decade or so ago, and there was big discussions involving lots of people about this, when it's linked to technical equipment, of course it can be taken away depending on the changes of technology. So that's why it was not considered in the overall height of the building. You can make your own minds up whether you think that was a good decision or not, but that was the reasoning. And there's another two examples there where hopefully whether you agree with the decision or not, you can see that there is a difference between something like the Chrysler building, where that spire is an integral part of the architectural vision, and something like the Hancock, where it's functional technological equipment which is placed on the roof. Of course, in the 10, 15 years since then, there's been a lot of examples that come around that are not as black and white as the issues I'm showing you today. But just to extrapolate that, where do you stop? If you do start to count this stuff that's plonked on top of buildings, where do you stop? Signage, water towers, satellite dishes, where do you stop? And so all I want to get across to you today is that there are a lot of factors that were considered in this decision that perhaps on the face of it, might not have, made sense, because the iconic antennae on top of the Sears were higher than the spire on Petronas. As a result of that discussion in the mid-90s, what we did was we created 4 criteria, although this tended to get overlooked, to reflect the changes that go on at the top of buildings. And the first criteria, or category I should say, is the height to architectural top. And it was this criteria, this category that the tallest building in the world, or city or country, became the leading category. However, we created 3 other categories. And by the way, this diagram shows the 5 tallest buildings in this category today. Taipei 101 in Taiwan being the tallest building, completed and occupied today. Height to architectural top. The second category was highest occupied floor, i.e. at what height above ground can you put man or woman in a permanent working capacity, permanent access, as opposed to a mechanical room or a lift machine room or something. And the tallest occupied floor at the moment is the Shanghai World Financial Center, which was completed about 3 months ago in Shanghai. And that is an observatory up at the top level, which you'll see is significantly above all the other buildings. The third and least glamorous is height to top of roof. And the fourth, and hopefully this will please a lot of people in the audience, is the height to tip. And what this category is recognizing is, irrespective of whether it's signage or antennae or spire or whatever magical thing the architect may say about it, this is measuring man's ability to put material at the highest point above the plane of the earth. And hopefully you'll be pleased to see that the Sears Tower at this moment in time, in terms of buildings, is the highest material in a completed building. We do make a distinction between buildings and towers. Buildings require people to become buildings, as opposed to telecommunication towers, where the vast majority of the height is actually occupied by non-people directed space, or no space in a lot of cases. So that's the world's current tallest, Taipei 101. The world's current tallest under construction, and not far off completion, is the Burj Dubai. And I'm going to talk a little bit about that in a moment or two. Just to finish on the criteria, mixed-use buildings. There's a lot of interest around the world in this change, which I'm going to show in a minute, towards mixed-use buildings. And any architects in the room may know that there's a lot of people who put a restaurant at the top of a building and a shop in the bottom and say it's a mixed-use building, which of course it's not. And we define mixed use. For a building to be mixed use, then a minimum of 15% of the total floor area needs to be an additional use. So it's 2 or more uses, with any one use being 15% or greater before it can be accurately defined a mixed-use building. And that's the criteria that we use distinguishing between buildings and towers. So on the left there, you'll see a telecommunications tower. We say if it's less than 50% of the height of the building is not occupied by usable floor, it's a tower. It's not a building. Okay, I now want to talk about some of the trends in tall buildings that have occurred in the past 10 to 20 years. First of all, we can say very clearly that there has been a massive increase in height of the world's tallest buildings and tall buildings generally. And this diagram is the average height of the 100 tallest buildings in the world, which you will see going steadily up and up each decade. If we actually extrapolate that to the tallest building in the world, this is the history of the tallest building in the world on the screen here, you will see that there has been a massive jump to the world's next tallest building, which is the Burj Dubai. Never in the history of the world's tallest building has any building gone more than 62 meters, or about 200 feet taller than any other building. And the Burj Dubai will be almost 1,000 feet greater than the Taipei 101. It will be 60% taller than the Taipei 101 building. And you can see it there, and it's not complete yet. And there's a lot of things that are incredible about this building. Just in pure height terms, we could, and of course maybe we shall, have a conversation about whether it's appropriate on sustainability grounds and others. But in terms of pure height, this is the first time in the history of mankind that the world's tallest building will be predominantly a residential building. Every tallest building in the world has always been an office building. And as you can probably imagine, an office building usually relies on a large floor plate, a large floor area. You know, your typical office, you want to step out of a lift, an elevator, into as big a wider open plan space as possible. Whereas a residential building is usually a much smaller building because there are less people per floor. It's more cellular spaces. And so the thing about this building is not only its great height, but its slenderness ratio, its proportion. Because the first time we're seeing this massive height, but we're also seeing a much smaller floor plate as it steps in towards the top, such that it really does look like a needle standing up on the Dubai skyline. Don't worry if you can't see these. If you want any of this information afterwards, I can provide it. But these are the tallest 30 buildings in the world at the moment, with Taipei 101 at the top. And interestingly, in number 10th place, the Empire State Building. Just keep your eye on that, because we'll come back to that in a second. Empire State Building built in 1931. Never been out of the top 10 in the best part of 80 years, Empire State Building. This will be the tallest 30 buildings by 2020. These are the ones we know of. So you will see Taipei 101. Sorry, actually, this is before 2020. This is approximately 2012, maybe. But Taipei 101 is now dropped down to 11th on the list. It's got the ranking of 1 because it's the tallest now. And the Empire State Building is nowhere to be seen. Nowhere in the top 30. Let me jump to this. This is easier to take in. This is what we call the tallest 20 in 2020. This will be the tallest 20 buildings in 2020. And these, by the way, we have strict criteria for these. These are what we call real proposals. And by real proposals, we mean there's a site, there's money, there's a developer, there's a full professional team, there's planning consent. This is not just a hypothetical proposal. That doesn't necessarily mean they will all be built, of course. But the intention is that these are real proposals, and there is a full team currently working it up. And they're often on site. So the Chicago Spire, which I suspect we may mention during this presentation, is also on this list. But the ones in dark color there are the built ones. The ones in light color are out of the ground and are already well on the way. And the interesting thing is Taipei 101, I think, is going to be 16th on this list, and things like the Empire State Building are nowhere to be seen. So this is the thing. Irrespective of the credit crunch, irrespective of the hundreds of proposals that we see every month that are not on this list, i.e. the hypothetical proposals, we can say quite safely that we are in the midst of a tall building boom, the likes of which the world has never seen, both in great height and in numbers of tall buildings. The last part of the 19th century in Chicago, there was a great boom in tall buildings in Chicago. In Art Deco New York and Chicago, there was a resurgence. In other periods in the 80s and 90s in Asia, what has happened in the last 10 years is that there has been a boom across the whole globe. And Lynn and her work at Chicago Architecture Foundation, some of the exhibitions that they've shown, has portrayed that. You know, everywhere, Australia, Asia, Europe, traditional cities in Europe which have been anti-skyscraper. Some cities in my country like London. Just a few weeks ago, Paris have even announced that they're now considering tall buildings built in the historic centre of Paris. There has been a massive boom in tall buildings. Whether all these are appropriate or not, we will get onto. Great increase in height, a great increase in number. As I've said, there are now more tall buildings in Asia than there are in the whole of North America. Think about that. 40 years, more tall buildings built in the whole of Asia than were built in 100 and almost 30 years plus in North America. Another trend, the yellow bar there, or the fleshy coloured bar, whatever it is, indicates location. So that's, this graph shows location. The fleshy coloured bar shows North America. And what you will see, the dark green is Middle East, the light green is Europe, and the other colour is, the other light green is Asia. Basically, it doesn't matter where they are. But what you can see is that by 2010, these tall buildings are being predominantly built in places other than North America. This is the 100 tallest buildings in the world, by the way, the super tall buildings. So for the first time, we are seeing this shift, major shift away from North America. You know, in 1930, 99% of the tallest, so 99 of the 100 tallest buildings were in North America. By 2010, in 2 years' time, that will be 22%. And similarly, it used to be 51% of the tallest buildings were in New York City, and by 2010, that will be 5%. Another trend, there's a complete change in function. For virtually the last 100 years, you could say that the tallest buildings in the world would be predominantly office buildings. And that's no longer true. We're seeing a major move towards residential and mixed use. And that's what this graph on the left is showing. The green is mixed use, the yellow is residential. And we're also seeing a change in the material in which these buildings are being constructed. Again, for most of the history up to the last 10 years, 10, 20 years, they were predominantly steel buildings. But now a lot of these buildings are being built in concrete or more common composite structures, i.e. a mix of concrete and steel together. And a good friend of mine who works in this very building, Bill Baker, who's the engineer at Skidmore, Owings and Merrill, who is building the Burj Dubai, says, so I'm stealing this from him, but I'm sure he won't mind. He says, and some of you may have heard him say this, if you'd have predicted the world's tallest building 30 years ago, you'd have said three things safe. You'd have said it'll be in North America, it'll be an office building, and it'll be built of steel. And now the exact opposite is true. It'll probably be built in Asia or the Middle East. It'll be residential, and it'll be built of concrete or composite structure. And the final trend that I'm seeing, that we're seeing, is this change in aesthetics, and we're going to talk about that in a little while. This change in aesthetics for tall buildings. So what's driving it? Those are the figures. What is driving this? Well, I think there are a lot of drivers, but I pick up on just four here. Some I think which you'll be familiar with, and some perhaps not, just to throw out there my thoughts. One is land prices, always been a driver of tall buildings. Price of land in the city and the desire from developers and others to exploit to the maximum the price of that land in developing into a tall building. So that's one of the drivers. However, again, the world has changed, and now tall buildings have always been used as icons. They've always been icons, and they've always been used by corporations predominantly for prestige. But something's changed in the past 10, 15 years, and these are no longer just about projecting corporations, the prestige of corporations. They're now about projecting the prestige of cities and countries in a global competitive market around the whole world. And you can see it in the titles of the projects. They used to be Chrysler Building, Chicago Tribune Tower, Sears Tower. Often, you know, the titles outlive the companies by decades. Sorry, that wasn't meant to be political. But now they're not. They're called Burj Dubai, Taipei 101, Chicago Spire. They've taken on a new agenda. And the agenda is that these buildings are being used to say, hey, we've arrived. You know, we're a first world country, often for developing countries. And back in the West, you know, these cities are saying, well, we arrived a long time ago. We kind of slept for a while, and now we've arrived again. And these things are being used, and the city governments and often federal governments and things buy into this in a big way. And they're now about branding cities as much as they are about branding corporations. By the way, you know, I'm not saying this is good or bad at this stage. I'm letting you make up your own minds. I've got very strong opinions on this, but I'll let you make up your own minds. Now, a third driver, which is, I think it's not as perhaps apparent, but a lot of people felt that 9/11 would be the death of the tall building. And certainly in the 6 months after 9/11, I think many people that were instrumental in making tall buildings happen felt that it would be the death of tall buildings. And I think 7, 8 years later, we can say, we can conclude quite clearly that it's not been the death of tall buildings. In fact, the opposite has happened. I think 9/11 has resulted in better designed, safer tall buildings, and that's a whole different conversation that we could have. But I also think, personally, that 9/11 has actually contributed to this boom of worldwide tall buildings. And I think the reason is because it was such a massive event, probably more massive than any event ever in the history of mankind, and the ability for computers and television and radio to project it all around the world, that it put the tall building as an idea into people's minds that perhaps would never have thought about tall buildings, including people like you and I, the interested public, but also developers and others in far-off places. So there was a definite period after 9/11 where tall buildings, some were shelved, some stopped, some were not considered. But I think that it actually became a contributing factor just because it was projected into everybody's conscience all around the world. And people began to ask, is it right to build tall buildings? And a lot of people in a lot of places obviously answered yes and started to adopt them in more number. And the fourth driver, and this is one of the thrusts of the presentation today, is sustainability and climate change, and what denser cities can bring with the responses to the changing climate patterns and challenges that we all face now. So let's go into that in a bit more detail. Please don't read the next few slides because there's lots of text on them. But before I tell you about the positive sustainable credentials of tall buildings, let me just say that there is strong, there are very strong feelings all around the world that in a lot of cases tall buildings are not suitable at all. You know, when I mentioned the Paris thing, there was a visible reaction from the audience, which to me is normal, coming from London and various other places. And certainly we as the council do not advocate saying tall buildings are the answer to everything everywhere. What we're saying is if you're going to do a tall building, then you should do it to the best that you can do, and that's what I'm going to touch on today. But there are many people who think that they're terrible, and there are many people who think they are anti-environmental. That the embodied energy, for example, in gathering these materials together and putting them up in the sky just doesn't justify the act of doing it in the first place. And the energy that's expended in elevators and lighting and all these things make them anti-environmental. And there are usually three areas that these people draw on for saying why tall buildings are anti-environmental. During construction and operation, the internal environment that they create for people, and the impact on the urban realm in terms of overshadowing, right to light, things like that. So I'm not going to dwell on this, but there's a whole list that I've put together of why tall buildings are anti-environmental. and you can ask me for this later if you want to. However, one thing that I do want to touch on is why we at the council believe that they are an important solution for sustainable cities of the future. And rather than dwell on that, let's dwell on this. I think it's generally recognized, and I mean no disrespect here, but the American urban planning system, which by the way the UK has adopted comprehensively, is not the way forward for cities of the future. i.e., we'll build a dense downtown core and we'll stick our offices there, but we can all go off and live in a quarter-acre block or wherever out in the suburbs. I think most people think that that's not the way forward for the future. The loss of greenbelt, the ever-increasing infrastructure, the transport networks, and this diagram for me shows why. On the left there, this is a diagram of private transport energy use per capita. And transport is a major contributor towards both energy usage and greenhouse gas emissions. So on the left there, we have models such as Houston, some of the American models, where people predominantly drive to work every day, often a 2-3 hour commute and back. And on the right there, denser cities, right down to Hong Kong, which is one of the most sustainable cities on the planet, because very few people own cars. And the investment is all in mass transit systems. And if you've been to Hong Kong, you are spoilt for how to, for ways to travel. Boat, bus, metro system, trams, funicular, whatever you want, you can travel there. It's probably the best transport system in the world. So denser cities that cut down infrastructure and all these things, all the infrastructure, we think has got to be one of the ways forward. Now, why is that relevant? Well, that's relevant in countries, let me move on to that slide, which I like. This is relevant in countries like China and India and other developing nations that are seeing millions of people moving from rural to urban every year. Figures have been done to show that China needs a new Chicago, something like every 8 months, to house its rural to urban migration. Where do these people go? And by the way, those figures might not be 100% correct, but the sentiment is correct. So where do these people go? Do they go in the American model of a dense downtown working core in an ever-expanding suburb? Or do they go into denser, what people say, more sustainable work-living patterns? But it's not just about places like China and India. Changing social demographics in countries like America and the UK also a result, and by changing social demographics, I mean people are living longer, divorce rate is up, single-family households. In the UK, we need 200,000 new homes every year for the next 10 years to cope with not increasing population, because population growth is more or less static, but the increased homes that are needed. Where do these homes go? And that's one of the things that we're advocating is in denser cities, which doesn't necessarily mean tall buildings, of course, but tall buildings can be one part of the solution. And one thing that we feel quite passionately is that tall buildings have an opportunity to show the way for the greater good of the built environment as a whole. And this slide, though it might seem a bit obscure, shows that. This slide is a testing rig that was put up to test one piece of structure for a building in South Korea. And of course, this piece of structure was probably going to be repeated 500 times in the building. Because of the size of a tall building, it has both an economic and a professional investment in it, which allows it to embrace experimental sustainable technologies and testing and other things that smaller buildings don't have. Now, this is where I start to get really passionate, because this is what I'm really passionate about. This is the second challenge of tall buildings. And it's what I call tall buildings and place, the shortfall of tall. And I normally, I often start my presentations here, and I start with a statement, which I hope nobody will be offended by. But I actually think that 99% of tall buildings around the world are really poor pieces of design, really poor. And I'll tell you why they're poor, because they follow one of two design approaches. They're usually the vertical extrapolation of an efficient floor plan, i.e. the commercial model, or they are designed as a piece of sculpture to be beheld in the city. Much as you design a piece of sculpture to sit on a mantelpiece or a table or anything else. You know, this iconic approach. And although the iconic approach can lead to more interesting tall buildings, the problem's this. When the relationship between a tall building and the city is purely a visual one, i.e. I'm here, I'm beautiful, look at me, then that building can be picked up and plonked anywhere around the world. And what architecture generally, but what tall buildings specifically are doing, they are homogenizing world culture. Cities are now getting more and more like each other because they're gauged through a series of imported icons. And this is something that myself as an architect, but also as someone who's passionate about foreign culture, and I've lived and worked all around the world, traveled in 50 or so countries. I travel to countries because I'm interested in the differences between places, not the similarities. And it offends me when I see tall building competitions pop up in, let's say, Chicago, and a tall building is unsuccessful, and then I see the same building pop up in Moscow, or Dubai, or Sydney, or London. And you know, I think architecture has got to be more than that. And I think for a large part of the history of the tall building, it was because we didn't have the opportunity to move materials around and move architects around and move professionals around like we do today. You know, if you look at, this is one of my favorite buildings, the Fisher building, there was a natural relationship between building and place, partly because of the materials that were being used. And I always have to be careful at this stage because I'm based at IIT, which is the home of Mies van der Rohe. So I'm glad that my dean is not here, unless she's snuck in at the back somewhere. But I think it all went downhill, started to go downhill with this building. Not necessarily this building or this architect, because I think this building, in many respects, is a fantastic building, but it was hijacked. It was hijacked by all those people who wanted the most efficient commercial model, i.e. what I call the rectilinear air-conditioned box. And it was superimposed in 1 million places around the world. You know, again, not to offend anyone, but Mies van der Rohe even did it in this city. And what I'm advocating is that every building should be unique, or at least should be born of its place, its direct place, its site, not just a box that is superimposed. Now, if anyone is offended of this, let me just say that if there's any place that the box belongs, then it probably is a North American city, with all due respect, because this is where it was developed. The commercial rigor here, or the commercial, you know, beginning of the building of the design is still relevant. So perhaps it is relevant in North American cities. It's not relevant in my city of London. You know, this is Canary Wharf. It's a piece of Manhattan adrift in the East End of London. What the hell's it doing there? You know, and you'll hear these architects talk with great passion about the design and this and that, but really a lot of these buildings are just clad commercial space. And I think tall buildings need to be about a lot more than that. There are some great buildings there, and by the way, I've got to confess that I often feel schizophrenic in talking this way, because I can get excited about any tall building. The technical achievements, the economic achievements, there's a lot to get excited about. But in my role as a professor at IIT, I also border to the utopian, and what I'm saying is that they could become and should become a hell of a lot more. So this is a great architect working in London with the tallest building in the UK, number 1 Canada Square. This is the same architect working in New York. And even between New York and London, shouldn't there be a difference? Is the angle of the pyramid on top of the building enough of a change? And in the cities that I've lived and worked out in Southeast Asia, this is how it translates. Air-conditioned rectilinear boxes, 99% of tall buildings, with some fun and games at the top and fun and games at the bottom. You know, look, the building on the right-hand side, actually, better image, Bangkok. I lived in Bangkok for 2 years. You know, what has postmodern architecture with a route back to, I guess, somewhere along the way, the heart of Greece or Rome, got to do with Thailand? I find this extremely offensive, but believe me, this is a large part of the normal tall buildings that are built out in Asia and other places. So let's look at how people move away from that. This is something that I call literal cultural symbolism. It's still a rectilinear air-conditioned box, but someone's put a mosque on top because it's based in an Islamic country. Is that a better response? Well, I'll let you make up your mind, but at least somebody's trying to think, well, we want to try and localize this. This is, again, literal cultural symbolism, i.e., this is Taipei 101, the world's tallest building. It's inspired by the Chinese pagoda. Is it appropriate to take a pagoda and inflate it through 88 stories? I don't know. You know, again, I ask you to make your own mind up. But at least it's a step in the right direction for me. At least someone's trying to create something born of place. Jinmao Tower on the left. Literal cultural symbolism. On the right, something I call abstract cultural symbolism. This is Con Pedersen Fox from New York. If you hear Bill Pedersen talk about this building, he will tell you how he was inspired in an abstract sense by the culture and Chinese culture, and how the square and the diagonal relate in that culture, and how the square changes to the diagonal at the top of the building. And that hole at the top of the building used to be round, and it used to be called the Moon Gate, until the Chinese weren't happy because it was a Japanese developer, and someone said, hey, it rather looks like the rising sun from the flag. So then they had to change it to a square. So that kind of sent the architect's conceptual thoughts slightly out of the window, on that element at least. But an abstract way of being inspired by local culture. You know, this is one of my favorite buildings. I go back to the schizophrenic thing again, you know. I lived in Malaysia for several years, and this is one of my favorite buildings. I think it's an incredibly beautiful building, but I still feel it could almost be anywhere. Now, Caesar Pelli, who designed this building, was inspired by Islamic geometry in the plan form, and that's why I show the plan form on the right-hand side, the Islamic star. But then he extruded what I think is mostly a Western tower from this Islamic plan form. It's still that same language of steel and glass. And ironically, just a couple of miles from this building is another building which is inspired by exactly the same plan form, but designed by a local architect. So it's the same plan form. But the architect didn't stop with the plan, because nobody understands a building in plan. You understand how it looks and how you move through the spaces. You don't understand it as a two-dimensional drawing. What the architect did was extrapolate into 3 dimensions and carry on this Islamic tradition where the materials were used to create this brise solaire, or fretwork, on the outside of the building, which also shielded the curtain wall, which was then set back in from the skin of the building. I think this is an excellent example of what I would call a vernacular skyscraper, a building that is born of its place. So I just want to chart briefly what I call the rise of an environmental conscience. Buildings that are responding to environment and place. And you know, we could start anyway, but I start with Frank Lloyd Wright. This building was pretty much a disaster in any other way than aesthetic. And you know, Frank Lloyd Wright is a hero of mine. I live in the heart of Oak Park. I can see 6 Frank Lloyd Wright houses from my window, from my windows. Frank Lloyd Wright's a hero of mine. This was his only real tall building, and it was a disaster in many respects in terms of its functionality. It mixed office and residential on each floor in a relatively small floor plate. But for me, it was interesting because Frank Lloyd Wright didn't believe that the skyscraper belonged in the city at all. He believed that they belonged out in the suburbs where they could be beheld, where they could be beautiful objects. But another point behind his rationale was, rather than go for this suburban model of everyone living on a quarter-acre block, put them up in higher-rise towers so that we can preserve the land. Now, there are obvious social connotations and things to that, but it was an interesting approach. So that's why I start here. Now, you may see this as an ugly lump of stone in the middle of the desert. You know, and that's your prerogative. But I see this as being inherently sensible. What I see as being inherently unsensible is building all glass towers in the middle of the desert, and then putting sunshades on the outside to cut down the glass, the solar heat radiation through the glass. And Skidmore, Owings and Merrill, again based in this building, I think have done some fantastic buildings, and this is one of their best. because this is a building which kind of shields to the sun through this stone facade and inverts the curtain wall, the glazing, to the inside through a series of sky gardens which step up, which hopefully you can see in plan there. Sorry, I should. These are a series of sky gardens, and this then is the glazed. This is the glazed facade, so people still get this view out, whereas the outside of the building is predominantly stone. I think there are lots of great examples in the Middle East of tall buildings that are not just constructed in stone. And I'm going to speed up a little bit because I want to show you something else towards the end here. But there's others that have done it. Harry Seidler in Australia, Charles Correa in India, that are trying to create something which is really born of place. And probably my biggest hero is an architect called Ken Yang. And I don't know if any, obviously someone's aware of Ken Yang. Ken Yang is a Malaysian architect, and I'm very pleased to say a friend of mine as well. And for the past 30 years, he's been going where everybody else has been talking about in the past 5-10 years, developing green skyscrapers. And, you know, there's two people that have really been doing it, Ken Yang and Norman Foster. Norman Foster has also done some excellent tall buildings, but there's a major difference between the two. Norman Foster's palette of work is still that high-tech, modernist ideal of steel and glass, whereas Ken Yang has really striven to create buildings which create a new aesthetic. And that's really the thing that I'm most passionate about. This situation that we're in with climate change, we've got an opportunity to create tall buildings that are born of our age, that look different to the last 50 years of steel and glass. And that's what I'm passionate about. So one of the things that Ken Yang does, one of the many things, he introduces greenery into a building. Something, again, though, I'm very passionate about. They're not enclosed boxes, and of course you can do this in tropical Malaysia, but they're extrapolated boxes to let air flow through the spaces, rather than all being enclosed air-conditioned boxes. No one was brave enough to build this building, unfortunately, but it's one of my favorites. And this rise of green as a material is interesting. It's really starting to gather pace now. You know, this was a token effort in the 1980s, but there are a lot of buildings where greenery is becoming, you know, the most important part of the threshold of the material palette, of the aesthetics. And long may it continue, I say. That greenery brings so much to both the architecture and the city through reducing heat island effect and various other things. How far do we go? And I'm going to breeze through this, but this is Norman Foster on the left here, built building the Commerzbank in Frankfurt, and Ken Yang on the right. And I kind of like this. This, for me, typifies where we're at, this green or grey. What is the aesthetics of the future tall building? Is it Ken Yang? Is it green? Or is it Norman Foster? Is it grey? And Norman Foster has built some excellent tall buildings, probably better than anybody else. Quality of internal space, the sustainable aesthetics. But look at this. This is the Swiss Re Tower in London, again, city in my country. Is this the best tall building in the UK? Probably. But is it really an eco tower? Because if it's an eco tower, why is it the same through 360 degrees? Because the sun isn't the same through 360 degrees, and the wind isn't, and the city certainly isn't. So, you know, architects tend towards I can't think of another word, so I'll say bullshit, and I'm sorry if that offends anybody, but they do. And, you know, I think there are great environmental aspects to this building, but it's essentially been designed as a piece of sculpture to be beheld. And I think it would be a lot more useful if architects would just say that. I'm not saying that buildings shouldn't be sculpture and shouldn't be beautiful, but there are certain things that should override it. And I think a true environmental tower shouldn't be the same all the way around, shouldn't be designed as a single object like that. You could say a similar thing about Hearst Tower. And then we have this not latest trend, sorry, it's not a trend. We have this tendency now to use sustainable technologies as an important part of the aesthetics of the building, glorifying. If we're going to put a wind turbine to harness wind energy, then it's going to become the main expression of the building. So on the right-hand side there, the Bahrain World Trade Center, that's a built building. And again, I think on many levels it's a fantastic building. So I'm not being critical of these buildings in any way. It's extremely brave. The client and the developer and the architect for the greater good of humanity, is willing to invest in 3 massive wind turbines to test whether it is good to harness wind at height, which people think it is, but the jury's still out on whether it's better to put them on the top of tall buildings or whether to collect them and put them all in offshore farms. You know, the verdict's still out on this. So I think we need to support these projects. I'm just talking about the aesthetics. And the final thing I want to show you is some of the work that I've done with my students. And I take a deep breath and advise you to do similar. But this diagram's interesting. What this diagram shows is the thing with technologies are often used to correct problems that didn't need to be there in the first place. And if you're designing a true environmental tower, you've got to get the fundamentals right. These are not by me and my students, by the way, but these are some models which interest me because they're moving away from all glass towers. If you're going to move away from an all glass tower, then what kind of language could you expect? And these are some projects now I'm going to show you. By the way, if I've criticized too much or be perceived to have criticized American architects, this is one of the UK's greatest high-rise architects, Richard Seifert. You may have heard of him in London. On the left-hand side there is the NatWest Tower, the building that's built on the extreme left. The idea behind this building was to take the logo of the NatWest, which you can see in red there, and extrapolate it through 42 stories. And I ask you, is that the best we can do as architects? I think that's atrocious as a starting point for architectural design. Not about the city, not about people, not about place, not about anything but this corporate entity logo. And would you ever know that looking at the building? It wouldn't be so bad if you knew it. Yeah, well, maybe bad, but at least there would be some result. But it's just a little bit of a game which nobody even knows anyway. Okay, one of the main differences between a tall building and a small building is this. A small building only has a relationship with the city or the site in its direct context, around the base of it. A visual relationship. Whereas a tall building, as it starts to rise up in the city, starts to potentially get a relationship with places far and wide in the city. And I believe this can become a starting point for manipulating the mass and form and expression and skin of the building. So there may be important places, urban parks, or the view from a bridge, where the building can start to set up a dialogue with other buildings and other places in the city. So these projects started to explore that to perhaps an extreme view. But this is twisting and turning depending on things that are going on in the city. This is a project that was right by the side of a Grade 2 listed church in London. And this was the architect's proposal on the right-hand side. And the architect said, I'll build a big tower out of glass because the tower will then dematerialize and disappear. And, you know, whatever architects say, 40-story towers, whatever they're built of, do not disappear. You know, the proposal we worked on the left was at least acknowledging the church and trying to have that influence on the design of the tall building. If you are going to harness wind in tall buildings, then what's the best way to do it? Is it 3 big turbines? Or is it what we call here, which is a wind farm? And by the way, this is me and a student at IIT. So, you know, there's not a great amount of detail behind these. I can't show you full working drawings. They're just ideas that are exploring what the possible future is. All these designs have a lot of ideas in them. For example, this leans in towards the south to cut down the angle of incident sun hitting the facade. This is a project, some of these are in Chicago, by the way. This is a project which takes this technology, which a lot of people believe is the way forward. It's not about putting photovoltaics on buildings anymore. It's about solar thermal power plants, which you see here in Seville, and I think one's just been constructed in California or Texas or somewhere, which is about concentrating sunlight onto a receiver and taking that energy and storing it through raising liquid into steam and powering a generator and various other things. So we took that technology and see if it could be applied to a tall building. Again, it's an agenda which is born of place. In this case, it might seem bigger with the climate change, but it's born of that place. Is it possible to do that? This is a project which we call the Chicago Aquifer. Water is the next oil in terms of crisis. There are projects in this city that tout quite heavily that they have rainwater recycling systems on the roof. Well, I hate to tell you this, but the roof of a tall building is negligible because rain doesn't fall down vertically. It's driven by wind. So rain doesn't do that, it does that. And if you're serious about capturing rainwater, then really it should be about the facade, not about the roof. The roof is tiny. It's the facade which is the big thing. So this project placed itself perpendicular to the predominant wind direction so it could capture 160% of rainwater falling on the site. How 160%? Well, it captures it from its site and the site adjoining. And then the facade becomes a device for capturing the rainwater and bringing back into the building for usage. There were other things going on. It took water out of the lake and purified that. There were lots of other things going on. There were living machines in the building. Does this seem absolutely nonsensical and silly? Well, at the moment, perhaps. But when we've got no water, absolutely no water, things like these might become, and having to capture every square millimetre of it, square inch of it, it might become more sensible. One of the things I'm passionate about, why are all tall buildings either office, hotel, or residential? Is that the best we can do? In our future cities, is that the best we can do? Because cities are made up of more than that. We've got to introduce non-traditional functions into tall buildings. And not only that, we've got to do one thing and make it count for three. So this is a tower which combines office and sports facilities. And this skin on the outside of the building is there to shield from the predominant southerly sun, but it's also, and I smile as I say this, but it's also a national centre of excellence for rock climbing. You do one thing, you make it count for three, because otherwise you've got to build your artificial rock climbing place somewhere else and transport people to get there. And could you imagine being sat in your office and seeing people climb past the windows? At the top of tall buildings, we have a tendency to put what are called mass tune dampers or liquid tune dampers at the top of buildings. It's quite technical, but could we put a liquid tune damper at the top of a building and use it as a swimming pool? If there are any structural engineers in the audience, they're instantly going to tell me no. But this is what we're doing at IIT. We're trying to just push the boundaries on what are possible. Oh, you might not be ready for this one. This is the hydrogen tower. This was looking. Part of the problem with tall buildings is where do you handle the car parking? I mean, the whole issue of car parking, the whole issue of cars and cars in the city. So these cars were powered by hydrogen, but the problem at the base of a tall building when you put the car park there is it disconnects the tall building to the city. So what we actually looked here was moving the cars up and down the facade in a carbon neutral way through use of hydrogen, and still fitting in with that suburban American ideal of being able to park your car on the driveway within a double skin inhabited facade. This is a serious one. I mean, they're all serious actually as ideas, but this is a serious one. This is a vertical farm, completely nonsensical that we keep importing and exporting foodstuffs all around the world with the food miles, the energy implications. So this was a project which built basically a big greenhouse on top of an existing building. And this is, let me tell you, there are a lot of people who think this is a really good idea because it's protected, it's inside, you built it out of a material called ETFE, which is light, you wouldn't build it out of glass, you've got no problem. It's grown through a system called hydroponics. It's not soil, because you don't want soil up there because it's too heavy. It's free from pestilence, it's free from weather cyclones. You can do it all the year round. There's people doing a lot of research into this, and it's giving the food source where you want it in the city. And the final project I want to show you picks up on that and takes Mayor Daley's idea of the green roof. Now, the green roof is excellent, and I think Chicago well deserves its moniker as got more green roofs than any city in the world. Great. And the green roofs reduce the heat island effect. They insulate the building. They create a recreational space. But what would happen if we started to link these green roofs up and started to actually create a green network in the city? And this introduces the final thing I want to say to you, which is one of my passions, which is sky bridges. As we make the push to denser, taller cities, it seems completely nonsensical to me that the ground floor, the pavement, the sidewalk, is the only plane of physical connection. We're going taller and taller and denser, and we need to start introducing sidewalks into the sky. And once we start to do that, it will change the whole dynamic of buildings. They'll have to start to talk to each other to be designed together. It'll bring people up at the higher levels where we can get public facilities at higher levels as well as ground levels. And this project looked to do that by linking up these green roofs, and the tall building became an interface for bringing that down to the ground. So this became a circulatory network within the city, a recreational network, but also a produce network for produce to be grown. You know, there could even be sheep and cows and goats up there. And just anyone who thinks that sky bridges are crazy, let me tell you this. Petronas Towers, there are lots of benefits. That bridge is fire rated. And that means that half of that upper population in the left-hand tower can evacuate across the sky bridge and into safety in the adjoining tower and down that tower. If there are any developers in the room, that allowed them to omit one fire stair from the top of each of those towers. Sorry, from the bottom of those towers. Now, in the light of 9/11, that's a whole debate we could have. But you know, one fire stair from each tower is a hell of a lot of floor area and a hell of a lot of money. The ideas between connected cities go back at least 120 years. Every science fiction film that you see, because of these people creating cities in the future, it seems sensical to have them connected. And Minneapolis is a good one. No, I haven't, but actually I haven't quite finished a PhD, but my PhD is on sky bridges, and Minneapolis is one to study. It's the opposite of Hong Kong. Hong Kong, you can get up on a elevated network and walk for 4, 5, 6 square miles without touching the ground. Same in Minneapolis and some of the cold northern cities with Hong Kong and the hot. These are conditioned spaces. Many of the problems that have then been overcome in terms of public-private realm and all the rest of it have been overcome in these cities. Why couldn't they be overcome at the higher level? And there are lots of projects around the world that do. I mean, ironically, of the 7 final proposals for the World Trade Center, 5 of them proposed connections between the buildings at some point, in some way. And here you see some of them. And then they had to go and pick the Daniel Libeskind one. But that's another one. And here's the Minneapolis, the Hong Kong connection. So, final slide. 7 design principles for future tall buildings. This is what I'm advocating with my students and anyone else who'll listen. Tall buildings should vary with height. They shouldn't be just vertical extrusions of an efficient floor plan. The texture and scale of the tall building should vary with height as well. I almost feel that a tall building should be designed as a series of small buildings which are put together in harmony. But what I mean by that is not that it becomes a whole mess, but that the care and thought that's given to a 3-story building is then given to the next 3-story horizon and the next 3-story horizon, rather than care and thought into a plan, which is then just extrapolated vertically. New functions need to be introduced. Kindergartens, schools, shops, doctors' surgeries, and if we had sky bridges, that would make it easier. This is key. Communal, open, recreational space. Social housing has never worked for high-rise buildings. Why? Because they never had these kind of spaces, as well as the maintenance and the upkeep and all the rest of it. But this is the thing. If we're going to recreate cities in the sky, we need to recreate cities in the sky, not just put people up at height. That means cities. Everything that's in the city, parks, neighborhoods, space, needs to go up in the sky as well, because you're concentrating those people on a smaller footprint of land. I think we've got to stop building all glass towers, wherever, but especially in the Middle East and in the desert. You know, I think the aesthetics of tall buildings have not moved on for 50 years. I think organic matter and vegetation needs to become an essential part of the material palette. And I think we need more physical, circulatory, social, and programmatic connections between buildings. There needs to be more connectivity between the buildings, not designed as standalone single pieces. If anyone's interested in any of what I've shown today, this is our website. We're a not-for-profit organization. Or you can send me an email, and I'd be very happy to supply you with some more information. Thank you.